We're delighted to welcome you to the 14th Annual New Horizons Forum. Yeah, 14th Annual. We just can't believe it. Time is flying by, and fortunately, innovation is marching on. And at GRF, we truly believe that collaboration is a key to innovation. And I think you'll see a lot of innovation today. We certainly have learned that putting different scientists together with somewhat different skill sets to collaborate on a common goal really catalyzes research discoveries. And we know that so many different skill sets are needed to take a research finding, an idea, and actually turn it into a real product. And that's why you'll see so many different skill sets represented here today. With our over 60 speakers. And we know that we need all these different skill sets to take a research finding, a brilliant idea, and actually get it all the way through to being a product, something that helps the lives of glaucoma patients. And that's really our vision. Our vision is a world where glaucoma patients keep their sight and even regain precious sight. And I feel like you're all a part of this journey of ours, this journey to vision, just by being here. And we hope that today that you'll all make some new connections, possibly come up with new ideas, and we hope that you'll all learn something. I always learn something here. But it does really take all of those skill sets to get to our vision, our vision of vision. And one of those very important steps, components to getting through from being an idea to being a product, is, of course, financial resources. And we have very strong support today that I'd like to recognize. I'd like to recognize all of our sponsors, because we literally could not put on this meeting without them. I'd first like to recognize AbbVie, our presenting sponsor. What the heck is a presenting sponsor, you might ask? Well, AbbVie's support has been so strong from the very beginning as Allergan and all the way through these many meetings. Your support, AbbVie, has been so strong, and I thank you so much for that support. Thank you also to our platinum sponsors, who have also been longtime supporters, Alcon, Bausch & Lomb, Glaukos. Thank you so much. And we've certainly seen so many changes at all of these companies, innovations that have driven their growth and helped glaucoma patients. Thank you to our gold sponsor, Zeiss. Thank you to our silver sponsors, Heidelberg, Sight Sciences, Topcon. And thank you to our so many bronze sponsors. Thank you all for being here and for this support. And I really do want all of you to meet these companies and thank them too, because we truly couldn't do this without them. I'm looking forward to an exciting day. We have amazing panelists and presenters. So thank you all for being here and being part of this journey to vision with us. And now I'm delighted to bring up my co-founder, Dr. Andrew Iwach. Andrew.
Good morning, Adrienne.
Hi, darling.
Got it. 14 years, but who's counting?
Okay.
Good morning. Welcome. Thank you for being here this morning. And let's go forward here. And there. Why are we here? The times are changing. This is the latest data from Medicare. My friends and colleagues at the Academy of Washington, D.C. office, Julia Lorton and Brandy Keys, just sent me this data last week. And this shows what we actually are coding, what we're actually billing for out in the field. Now, it doesn't represent all patients, but a lot of patients are on Medicare. The red line I'll draw your attention to, that is the number of times we have coded for trabeculectomy. The white line is iStent. There's a little purple blue line that's showing the implants such as Hydrus and iStent. But if you'll notice the purple line, that is showing goniotomy, the brown line showing canaloplasty, and the point being there are a lot of changes occurring all the time. So staying in touch, what we're doing here today is impacting how we can help our patients. In fact, I believe, Adrienne, there were no MIGs approved when we started. So we've certainly come a long way and went from an idea to actually solutions for our patients. We also have an ongoing partnership with MarketScope. This is our 10th year, and the relationship is that tomorrow we have 380 ophthalmologists signed up in the morning. We have about 400 optometrists signed up in the afternoon. And if they complete the survey, MarketScope will make a donation of $25 to the Glaucoma Research Foundation, and the participants get access to the data set. And that's really worked out well. We do these well in advance, so later on for next year, if you have a particular question or something you'd like us to maybe pose to these two audiences, let us know. We collaborate with them. Some very early results from this year. Again, these are just early results from this year's survey. One of the questions of many that we asked is gaining access to the superciliary space important or useful for pressure reduction? Well, at least half the people in this particular survey thus far indicated that, yeah, that could be a good place to go and might be useful for our practice. For the optometrist, we asked a different question. You know, with people who have dry eyes, you know, does that impact what you do? And interestingly, a fair number so far said they use preservative-free drops, yet a number of them didn't seem to kind of link the importance of actually other things that we can do. Again, this is early in the survey, but if this is held to be true, then that is an opportunity for us to educate and help them, all of us, understand the importance how glaucoma and dry eye interact. But there's more that we interact with in glaucoma, and I'm pleased to announce that next year, New Horizons, no change, but on Saturday, we will be adding a retina symposium. So next year, in the morning, we'll have glaucoma for the MDs, and this is actually a live website. This is up and going now, where with one entry of data, you can either sign up for one or both programs. We anticipate that this will be well received. And so next year there also will be an opportunity, there'll be a lunch break, and I suspect some industry partners may want to take advantage of that from between the morning glaucoma meeting and the retina meeting. Again, that'll be on Saturday, the CME we're adding, and that'll be for January 31st, 2026, and that QR code is live. People are already registering. Also, we do have Wi-Fi courtesy of AbbVie. The password, surprise, surprise, is AbbVie. So if you have any troubles, let us know, but that's available throughout the meeting area. And of course, the app, download it at Bismo app and go to My Events. You should see Glaucoma 360. Lots of information, program, easier way to contact people here at the meeting. So a great resource for you for this meeting. For those of you who are on social media, hashtag Glaucoma360, please post early and often. We appreciate it, getting the word out so that people know what we're doing here. This is important work. And now I have the pleasure and honor of introducing this year's Henry and Frederick Sutro Memorial Lecture. Dr. Sutro, who pictured here, was actually one of my patients many years ago. And he said one day, you know, I'd like to do something to help research, and boy, did he. This ended up with a $3.2 million bequest from him. He was on the faculty of the Pacific School of Dentistry. He practiced in Oakland, and only after he passed did I realize the Sutro name, that he was actually one of the, he was the great-grandson of one of the former mayors who at that time was one of the largest landowners in San Francisco. I didn't know until after he passed. This is a picture of the really premier KOLs that have delivered this lecture in the past. We've been honored to have them here. Some are here in the audience, and we thank you for your excellent presentations in past years. And this year, it's my pleasure to introduce Carla Siegfried. She is on faculty at the Washington University School of Medicine in St. Louis. She is a distinguished professor of ophthalmology, vice chair of diversity, equity, and professionalism. She has received many awards. A short list of them include the Schaefer Prize back from the Glaucoma Research Foundation. She's a Secretariat and Senior Achievement Awards from the American Academy of Ophthalmology. She's been inducted into the American Ophthalmologic Society, a huge honor, and currently president of the American Glaucoma Society. Her research interests are significant, but she's a great clinician. She also focuses on some of the issues with racial disparity, and she's a great role model and mentor to all, but also to women. And that leadership role really makes a difference. We need help from everyone. And with that, I'll invite Dr. Siegfried up to give her presentation. But before she speaks, I'd like to present you with a plaque to commemorate as a token of today's presentation. Appreciate it. Dr. Siegfried.
Well, thank you so much, Andrew, for that kind and generous introduction today. I'm so honored to be here on the podium presenting the Sutro Memorial Lecture. It's extremely meaningful, and I'm so excited to be speaking about glaucoma racial disparities, especially in today's environment where there are some potential issues of bringing these topics to the forefront. And I look forward to future innovations that will help us to address these issues. But we're going to talk about where we are today. Again, I'm extremely honored to be added to this list of presenters of this incredible organization, and I can't tell you how important it is to be here today. So I want to start with a case. And today's case is a 53-year-old black woman who referred from an optometrist with a history of possible glaucoma. She went every 3 to 4 years for an eye exam. She had mild refractive error, and she did have a family history of glaucoma as well in her mother and maternal grandmother. Her vision was 20/20, and I'm going to just cut to the chase here. Her pressures were 22 and 20, and these are her visual fields. Pretty shocking to see this on a first exam of a young woman showing this severe damage encroaching on fixation. So now we'll turn to some of the topics of today, including just what are the racial disparities of glaucoma and what are the challenges in studying these racial disparities in terms of stratification, genetic studies, social determinants of health, and then how can we innovatively address these with interesting solutions, including new ideas about stratification, even cell biology, potential targeted therapeutics, as well as addressing social determinants of health and community engagement. So what is innovation? And this symposium is all about innovation today. And really in talking about new ideas and that have a significant positive impact in so many ways for our patients. They must be creative. We talked last night about how one has, to be an innovator, you must have grit, perseverance. Absolutely, no question about it. But this is really how we can cultivate innovation to be the cornerstone of our scientific progress, and it is necessary to go to the next steps. If we look at the 3 age-related eye diseases, cataract, macular degeneration, and glaucoma, only glaucoma shows a significant racial disparity as we get older. And you can see that in the red column that rises throughout one's lifetime, demonstrating the disparity between blacks and Caucasian patients as well as Hispanic. So what are these disparities? And if you look at some of the older studies, back to the Baltimore Eye Study, 1991 publication, 6 times the level of prevalence of glaucoma, 16 times more likely to result in blindness, diagnosed earlier with more rapid progression, and ocular hypertension with a higher conversion rate, as well as thinner corneas, which may be an independent risk factor for glaucoma. So if we now look at some of the newer studies over the past decade or so, that individuals of African descent also have a higher risk of developing visual field loss with higher mean pressure. The All of Us cohort, which I'll talk about in a little while, indicated also that not only Black, but also Hispanic, Latino participants are diagnosed at a younger age. And in the OATS 20-year follow-up, a greater cumulative incidence of glaucoma as well, and presenting with more severe disease, as we saw in our patient, even when corrected with socioeconomic status. So why do we have these disparities? And how can innovation help us to address and develop solutions for these disparities? Well, first, we have to talk about the elephant in the room, and that's the question of what is race. And we understand that race is based on physical traits and how we self-identify. But it really is a social construct. And that is a really key point, because ethnicity is something that's different in terms of shared culture. And our categorization and terminology is very challenging. In the current scientific literature, the terminology to be used is Black and white. You will see in some of the studies that I present that other alternatives, African American, Caucasian, are also used interchangeably. So please bear with me as I present some of this data, because human studies are inherently messy. We all have different exposures, and it's very, very challenging because there's no suitable animal model. There's limited ocular tissue available. Yes, we can obtain tissue from cadavers, but we need to find better ways to obtain tissue from our patients with glaucoma. And how do we identify race? Well, self-report can be very inaccurate depending on the admixture of a population. Take, for example, Brazil. The accuracy of self-report is really quite low. And the stratification, of course, is non-binary, and our actual genetic ancestry may be inconsistent. So we need to look at genetic assessments. And you can look at things like Ancestry.com or 23andMe that uses a microarray analysis. And these microarrays are available. You can buy a kit on the market, and this is what was used in the All of Us research program sponsored by the NIH. And I will say that these ancestry informative markers that really identify the geography of one's origin can be very beneficial in determining who is truly of African descent. And I will call this innovation number 1. And here's an example. We did a small study of ancestry informative markers. And again, this is available. You can purchase the kit. And if you see here in purple, those are the people that self-identified as white. In red, self-identified as Black. And you can see it correlates quite well with the ancestry informative markers here. But there's still some individuals in the middle who identify as one or the other, but their ancestry may not be so binary. So now let's take a look at some basic science. And we're going to go back to, remember back in biochemistry and learning about mitochondria. So mitochondria are present in every cell, and they are the powerhouse of the cell. They're important in energy synthesis, reactive oxygen species as well, and including the initiation of apoptosis. So what about the DNA of mitochondria? Well, the DNA of mitochondria is a circular DNA, and it's much, much smaller. The number of base pairs is much less than that of our nuclear DNA. It follows direct maternal inheritance, so your mother's mother's mother, and it really gives us clues as to evolution to determine the human lineage all the way back to Africa. But it is highly susceptible to mutations. So if you take a look at the mitochondrial DNA tree that's rooted in Africa over 150,000 years ago, individuals can be categorized by haplogroups. And for example, the L haplogroup represents those individuals whose mitochondria were originally African origin. And this may influence the severity and penetrance of a variety of diseases and actually indicate unique responses to genetic or environmental patterns between populations as well. So we're going to call this innovation number 2, that we can stratify individuals based on their mitochondrial haplogroups. And this is the mito map, and as you can see in the African continent, that the L subgroups are noted there, Ls 1 through 4. So what about genomics? What about genome-wide association studies, which compare DNA of whole populations to identify gene variants that are associated with a trait or disease? So GWAS has identified currently over 120 unique risk loci for glaucoma. And some have large effects, but if you add them all together, it's still less than 10% of all glaucoma cases can be explained with these loci. And we don't understand the impact of these loci on prognosis, therapeutics, et cetera. So we have a lot more to learn. And the populations that were included in these GWAS were predominantly European and Asian populations, and less than 2% as of 2019 were representative of African ancestry. So, and there's a lot more complexity to this because it's not just whole genomics, but there's also tissue genetics as well. But as we increase diversity in our GWAS data sets, we can learn so much more. And these are some examples of how we have expanded our GWAS to include individuals from African ancestry. And I will call that innovation number 3, because now we can utilize some of this data to identify additional loci. In fact, a recent study that was published earlier this year identified 2 risk variants that were validated in independent data sets to be correlated with risk of glaucoma and also associated with cup to disc ratio. So we're getting there in terms of improving our diversity in genomics. The cancer arena is far ahead of us in how they have utilized genomics to establish information for precision or personalized medicine. And they not only have more accurate genomics, but genetic counseling and training, targeted therapies, screening, and this entire genetic cancer risk assessment. If I were dreaming at night, I would be thinking about a glaucoma genetic risk assessment. And now that we have increasing diversity in our GWAS, we can perhaps identify more loci. We have more endogenous factors. We have already, for example, the OATS EGPS risk calculator, targeted screening, family history, and someday targeted therapy. So I'm going to call this innovation number 4 that has yet to be achieved, but is out there ready for any one of the individuals in this room to develop something like this. So we're getting there. We have bits and pieces of it, and I believe we will get there soon. So now I'm going to take a trip down the road of serendipity, and serendipity is very important in science. And I'm going to bring the laboratory to the operating room. Several years ago, I was invited by one of the basic scientists in our department, David Beebe, who was a dear mentor of mine. And he wanted to have a clinical collaborator in order to look at oxygen levels in the eye. We were looking at oxygen and determining risk of cataract following vitrectomy surgery. That was sort of the first step. And so by utilizing a 30-gauge needle through a paracentesis site, we placed this fiber optic probe, as shown in the lower figure, into the eye and obtained real-time measurements of oxygen. And these were in patients undergoing cataract and/or glaucoma surgery. And we found through this avascular source, where there's diffusion of oxygen across the cornea, that there was a very stable gradient, very surprising, and that the environment inside the eye is hypoxic. And if it doesn't remain hypoxic, things happen, like cataract formation and perhaps even glaucoma. So as you measure this gradient from the posterior surface of the cornea to the anterior surface of the lens, the numbers are amazingly stable. But when we analyze the data, and here's where serendipity comes in, we identified racial differences. And of course, yes, this was self-report. And at each and every one of the 5 locations in the anterior chamber, we identified a statistically significant increase in those of African descent. And we were very shocked. Didn't have an answer as to why this could be. Is this an important physiologic difference? Does it represent differences in metabolic activity, oxidative metabolism, glycolysis? We didn't know. There was one study we found looking at the exercise physiology literature that indicated that there is a difference in VO2 max in individuals of African descent. But we didn't know. Is this a genetic basis? So we wanted to explore further. Just like every good hypothesis, you want to explore further. And so that's what we did. And the best way at that time to obtain cells from the angle was to perform a trabeculectomy. And as we saw on the photo, not many people do trabeculectomies anymore. I still do. Thank you. So we obtained these specimens, but they were contaminated with cells from the cornea, from sclera, and these procedures are usually performed in patients with advanced stages of disease. But with innovation, we are now taking specimens from goniotomy procedures, which are performed in all stages of disease severity, and we obtain precise tissue, and this was confirmed not only histologically, but also functionally. So this is innovation number 5. Now we have tissue that we can study, we can do PCR, we can culture, we can do all sorts of things. We can look at mitochondrial function and endogenous antioxidant protection as through the NRF2 pathway or through ascorbic acid and see differences. Again, this was still self-report at this time, but racial differences in basic physiology. And we can perform RNA sequencing on these cells and identify differences in gene expression. We even found differences in some of the mitochondrial elements. More questions for sure. We know that there's a correlation or there's information about mitochondria and glaucoma, that mitochondria is associated with oxidative stress, oxidative damage, leads to issues with the trabecular meshwork. We've known that for decades. But is there a correlation also with TMDNA oxidative damage, 8-hydroxydeoxyguanosine levels? Yes, with elevated pressure and visual field defects. And it's the back of the eye too, in the optic nerve and retinal ganglion cells. And so all of this is coming together that maybe mitochondria really have something to do with this. So now if you go back and you look at mitochondrial haplogroups from African areas, remember the L's? Well, those that are non-L3 are actually risk factors for developing open-angle glaucoma. And this represents about 25% of all African Americans here in the US. And that this risk of glaucoma may have actually emerged as people migrated out of Africa. All sorts of adaptations, and remember, we talked about how mitochondria have high mutation rates, mitochondrial DNA. So this is innovation number 6. Now we can not only stratify, but also identify how mitochondrial haplogroups can be risk factors for glaucoma. So now we get to take this from the bench to the clinic. And again, going back to our biochemistry, this is the electron transport chain. And these are the mitochondrial complexes 1 through 4. And you can see there on the bottom, nicotinamide and NAD. Actually, I want to go back. I just want to mention metformin because we're also doing some studies looking at cell senescence in the trabecular meshwork, and there seem to be differences in those of African origin, and now we are utilizing metformin to see how those are affected. But we're going to go with nicotinamide for the moment, because we know that NAD is a potent mediator of axonal and neuronal survival, and along that NAD synthesis pathway, nicotinamide, vitamin B3, increases those levels. And there are decreased serum levels of nicotinamide in patients with glaucoma. In a mouse model of glaucoma, nicotinamide dietary supplementation or even intravitreal gene therapy has been shown to be neuroprotective against glaucoma, with a relatively good safety profile, and we'll get to that in just a moment, we still need surrogate clinical markers. And so there have been a few clinical trials. This was a small study with just 32 patients for 2 months, followed utilizing doses of nicotinamide up to 3 grams, as well as pyruvate, with a primary outcome of improvement of visual field. So this is how you have to run these studies, looking at neuroenhancement or neuroprotection. We're not looking at IOP changes, much more complex. And this has been somewhat controversial because of the challenges of a short-term study and all of the fluctuations that we see in visual fields. There's currently a clinical trial that is recruiting patients as we speak. Jeff Goldberg here at Stanford and Aki Shukla and Jeff Liebman at Columbia in New York are recruiting for this prospective randomized study looking at placebo versus nicotinamide and pyruvate supplementation. Their primary outcomes looking at visual fields as well as RNFL and GCL thickness. However, there have been a few cases of liver toxicity, so beware. That's why we do clinical trials, to be certain of safety. Safety is absolutely important. So now we get to take what we learn in the clinic and what we learn in clinical trials to the community. And this is where we see many barriers in terms of social determinants of health, whether it's from education, healthcare access, the neighborhood we live in, our social and community context, and economic stability. So many factors involved here. And the result is disparities in healthcare, with lower quality of care compared to our white counterparts, with adjustment for income levels, insurance status, and even education. Inconsistent follow-ups, lower rates of testing, ancillary testing, lower rates relative to risk, and access issues, including cost and health literacy. So there's lots of issues here. Lower rates of outpatient glaucoma care, public insurance coverage with Medicaid results in fewer follow-ups and less frequent testing. All of these are issues, and that socioeconomic status correlates with poor visual function and ethnicity. So what's happening in our clinical trials? What's happening? Are we recruiting enough patients that we can learn about how these interventions affect all people with glaucoma? Not so much. And you can see here the difference between the black line, which represents white patients, and the red line or orange line that represents black patients. I said that backwards, white, black. And when that line, there's a big difference between those lines, that shows we're not recruiting appropriate levels of both populations. But if you look at way back in 1994, there actually was pretty good recruitment of the black population in this study. And that was actually the ocular hypertension treatment study that intentionally recruited black patients. And so I think that's really a key point, that we need to intentionally recruit individuals from all ancestry. I want to mention the All of Us research program, which some of you in the room are involved with. It's really an amazing database that is still being formed, sponsored by the NIH, with a target of 1 million subjects. I'm not sure where they are on recruitment, but it's a really diverse database and looking at so many factors of our patients, including environment and lifestyle, and many researchers are involved in looking at this data. And I think this is innovation number 7, because it really will allow us to learn so much more, not just genomics, but all these other factors that affect our health and our lives. And finally, in terms of community engagement, and this is just one model, I think it's an excellent model, but it really shows how we need to become woven into the community of our patients, that healthcare needs to be part of what they do. And the only way to do that is really to become involved and have all the stakeholders at the table who can really engage members of the community. So this study also showed that through not only that engagement in the community, but concordance of race and ethnicity between the provider and the patient. And that's an important factor, especially when there are issues of trust and and challenges of the culture. And that I will call innovation number 8, how we can get into communities. So let's go back to our case study. This unfortunate 53-year-old woman who came in with very late stage disease. What do you think her level of education was after hearing this presentation today? Her income, health literacy, what was her access to health care? She was a surgeon in a major academic medical center. So this just goes to show what our bias may be and how we need to learn so much more about the complex issues of racial disparities. So in summary, we have a lot to learn. I think we need to look at mitochondrial differences. We need to look at cell biology, because that may be some of the answers, some of it. It's going to be multifactorial. And explore novel therapies that may specifically relate to some of this cell biology. And understand and mitigate some of these issues of social determinants of health as well. We need to engage all levels of care, all individuals who are involved in research at the bench, in research in the clinical setting, as well as the community. It's going to take everybody. And I just want to thank the team that I work with. We are small but mighty. And I have a wonderful collaborator at University of North Texas as well that does our redox assessments. And I especially want to thank Glaucoma Research Foundation, because by the funding that I received through Glaucoma Research Foundation, it allowed us to continue our somewhat risky, innovative work and allow us to get federal funding down the road. So really, it really makes a difference. And just want to end with a quote by Steve Jobs that innovation distinguishes between a leader and a follower. Thank you very much.